We return after lunch to Water Hall and our next speaker, Leszek Krupiński, CD Projekt RED. Please.
Hello, everyone. Today I will be giving you a very short introduction to cloud services for gaming, meaning that what cloud vendors have to offer for the game dev, because quite recently the vendors noticed that there's a huge market of for supporting games, online games, and also games with the support with any kind of online presence. So just to give you a heads up, because there's still time for you to switch rooms, it will be about cloud and about servers, nodes, virtual machines, and things like that. So so it can be quite dry, but let's start. My name is Leszek Krupiński. I'm working for CD Projekt RED for more than 3.5 years, and I'm a lead software engineer at online services department, and that department takes care of everything that's online related within our games. So we support our game designers, game developers with anything they would like to have with regards to online presence. And a little heads up. Everything that we have tested was created under research program, the sectoral program called Seamless Multiplayer, and because of that we had huge liberty of experimentation. So we tested a lot of different things. So you don't have to. Okay. But since I will be talking about a lot of technical stuff, we can have some imaginary character to guide us through it. So let's meet that guy. Let's call him Leszek, and that guy is working for a game dev company that runs some games with multiplayer component, and he does everything by himself. This is his job. He does a lot of things, and he does them manually in the traditional way, meaning that he has some game servers. He hosts them on their own machines. When there is a new version of the game, he has to deploy it to the servers manually. So he has a lot of like handcrafted scripts for his tasks. So he has a lot of nervous situations when his scripts just blow up, because that's happening. It's kind of unpleasant situation, but DevOps guys have to deal with those situations. And when those scripts crash in the middle of the deployment, some of the servers are working on different version than the others. Some of those have started, some haven't. So it's difficult situation. The game is not working at this moment, so the gamers are unhappy, and they write some mean stuff on the internet about the company. So yeah, something needs to be done with that. All the cool kids, like for, I don't know, 15 years now, are taking advantage of the cloud, and the game dev industry was kind of reluctant to put their game servers on the cloud for many reasons. For instance, it was the price, but also the issues with some specific requirement of the game servers, because those had to be started quickly, had to didn't work very good with virtual machines, and the cloud is, it's fancy name for someone else's computer, and on those computer the cloud operators are running some virtual machines. So so the game servers sometimes don't play nicely with those, but since other people are using those, so why not for Gamedev? So a very brief introduction into the cloud, because like I said, it's like it's a meme now that every talk had to mention cloud, but I will try to make it brief. So cloud services have different levels, different tiers. So the most baseline is infrastructure as a service, meaning that you rent out computing capacity on some virtual machine. So most likely it's quite similar to what you get from running a virtual machine on your own infrastructure. So you have to install an operating system, configure it, set up networking, and so on. The next level, platform as a service, where you want to deploy your application, not thinking about all the operating system level stuff. Next, software as a service, where you just rent out access to some service that is being run in the cloud. Like everyone has some experience with that, because things like Gmail is also application software as a service, because you pay or not, because sometimes they are free, and it is software developed by someone else, and you just request access to it from its operator. And something even more ephemeral is a function as a service, where you just upload some code to the panel, and this code has some input, has some output, and it's being run by the cloud operator, and you don't care at all how it's run. You just expect for it to work, and you pay for the amount of time it's working. So so if you have things that require working only from time to time, it can be cost effective, because you don't have to manage all the machines, and you don't have to pay for the time it's not being used. So that's the cloud, and how we can use it. One of the simplest forms of using cloud services to make our life easier is using server templates. For instance, you have your own. If you had your game servers running on your own dedicated machines, so you had when you knew that you are releasing some new version, there's going to be a huge influx of new players. If you want to be prepared for some increased traffic, you would have to purchase new hardware, install that, configure everything to hook up with your management software, and with the cloud, you could create a virtual machine template, meaning that you have a virtual hard drive. You configure it to include your game server, your application, whatever you like, and you can just with one click just spin up new machines, create them, and make them working. So this is the simplest form of scaling. You just create a template and tell the cloud operator how many instances of those machines you'd like working. But you can make that even smarter, because you can have that being scaled automatically. So so when you have a template of that machine, so you have that description of what has to be run. You can configure this auto-scaling groups that will spawn extra machines based on some some parameters. So for instance, you can use some built-in metrics, meaning that you can tell the cloud system to spin up a new machine if the average CPU usage on all the other machines is above some threshold. Or there is the network traffic exceeds some level. So that works out of the box. So you can have that running in like 15 minutes. So this is the thing that that cloud vendors offer for everyone. And if you have some specific requirements, you can create some custom metrics. So for instance, your game server can expose some metrics, meaning that the game server is occupied, it has like 20 player slots and already 15 players are playing. So if you expose those metrics, you can configure this auto-scaling group to create new servers to reduce the average load of your servers. But this was the most basic form, and it's the server templates have some downsides, meaning that you have to still work on the operating system level. So your server template has to be created with some operating system on the bottom, everything installed. So you still have to worry about some lower level problems. But there are some techniques that make it a little bit easier, like containers. Containers is also all the rage with web applications for some time now, and the most popular system to implement containers is Docker. And what containers are? Containers, like the name might suggest, is everything that needs to be that's required to run your application bundled together. So for instance, if you have a game server that has your server binary, some libraries, some extra, I don't know, in-memory database that needs to be run with that, you bundle that together, and this package can be run as a single thing. Why that makes life easier? Because, for instance, exactly the same code can work on your development workstation and on the production environment. Well, sometimes it doesn't, but that's the general idea, that you work on the container. You can run that container on your own computer. With that being, it doesn't matter if your workstation is Windows, Mac, Linux. It will work more or less the same, like on production. And usually for production, we use Linux machines, so it will work in a similar manner. And of course, that's very important, because a lot of problems stem from the differences between the development environment and the production environment. So it's a typical situation when something works on development, on testing, and you deploy it on production, and it doesn't, and who knows why. So that's why the containers make it easier. The deployment of those containers is very, very easy. You don't have to upload anything in some magical ways to some servers, to some deployment CI pipelines. In the easiest way, you just push that there is something in the Docker ecosystem. There is something called container registry, which is a place that holds containers, and you just using the Docker built-in commands, you can just push it to the registry, and on the production side, you pull it from the registry and it will work. So So the deployment is very easy. The scaling is also very easy, especially when you use some container orchestration systems, and I will get back to that later. But there are some issues that we stumbled upon. For instance, there is the problem with the image size limitations. Image meaning that the application, how large the application is, because we have for our tests we used some almost full games. So our game server images were like 15-20 gigabytes, and it was too much for Docker. Also, it requires registry, the components to upload your containers to. It's not that big of a deal because most of the cloud vendors have them. Docker is supported by Google, by Microsoft, by Amazon. So they give it to you like for free for the cost of storage, and but it's something to be aware of. And also it makes the networking a little bit more complicated, but also I will get back to it in a moment. And the orchestration, because Docker container is something that that you start as a single unit. It works, and it might when it finishes working, it might just shut down. But there are some tools to orchestrate those containers, the container orchestration systems. The most popular one being Kubernetes. And what they do, they take advantage of all the computing power that you have to spread the containers over your machines. So how does it work? When you have the Kubernetes installed, or you use Kubernetes from the cloud vendor, you hook up all the virtual machines, all the computers that you have into a single cloud, and Kubernetes deploys your containers to one of those machines. You don't have to know which machine it's installed on, because it's also handling all the networking. So you have your container working somewhere within your machine group. Also, Kubernetes can take care of scaling. So when you deploy your container to your cluster, Kubernetes cluster, you can say, okay, now I want to have 20 instances of this container, and Kubernetes will scale them up. It will take care of load balancing those, meaning that it can spread the network traffic among those containers. Kubernetes is open source, free to use, so you can have it self-hosted. You can have your own development cluster on your machines. You can also install it on virtual machines in the cloud if you'd like. But also you can just pay the cloud vendors to host it for you, because it's industry standard for right now. So it's very popular, and also GCP, AWS, Azure, it's the most popular ones. It works there, and also on many smaller ones. So this makes the handling of your workloads easier. But I also said that it makes networking a little bit difficult. And why? I will also very short introduction about how Kubernetes is built, because the container is not the smallest part that you can work on on Kubernetes cluster. Smallest thing is the pod. Pod is a single unit that combines one or more containers, and the simplest one has only a container. This one has some container and a storage unit. This one 2 containers, 1 storage unit, or anything more complicated. So it contains everything that's necessary for the application to work. Like I said, you can have a container for your game application and a container for some database. You can keep it together. And why that's important? Because this is the smallest unit, so it always will be on the same machine. So Kubernetes makes sure that there will be no issues with communication between those units. And those pods works on nodes. This thing is a node, which might be understood as for instance, virtual machine. Virtual machine or physical machine, however you'd like. And within that node, you can have multiple pods. And why that makes the networking difficult? Because you have another level of abstraction. So if you had this application installed on your virtual machine, you would use this machine's IP address. And since this is inside this this node, it's called kubelet, a lot of cubes. It has to have some way of communicating inside this networking layer. So so it can be a little bit difficult to organize everything, especially if you have a little bit more complicated requirements. So for instance, one game server is hosting multiple sessions, working on different network ports. You have to find a way to translate those inside ports to outside ports. So it requires a bit of tinkering, but there are ways to make that easier. Yeah, like I said, it's why it's more complicated. It's the complexity of the whole solution is more difficult. When you want to have your solution scaled automatically, you have 2 layers. First of all, Kubernetes can add additional pods to run the games, game servers, applications, whatever you need. And at some point, it might be the situation when you run out of the nodes of computing power to run it. So you can use the scaling capabilities of the cloud vendor to add additional virtual machines. So that's the second layer of scaling, and also having that working fine with the game servers is can be a little bit complicated because, for instance, you are running some multiplayer game. You are running out of capacity. And game servers quite often require a lot of time to be spun up because they load a lot of assets. So, for instance, it takes 5 minutes to start a new game server. So every additional pod will take 5 minutes to start up. And if you run out of space for pods, you have to spin up a virtual machine, and it takes even more time. So you have to have your system ready for that to keep your game servers pre-warned. So waiting for the players to come. So they might be empty, but sometimes it's better to keep empty servers running than to wait 5, 10, 15 minutes to start new servers. And to make it easier, we started using Agones system. Agones is a tool that's talking with Kubernetes because it was created with Kubernetes in mind. It's hooking up to the database of Kubernetes, and it's dedicated to dedicated for game servers. So it's created for gaming, and it understands gaming requirements. Like it can handle having it can handle the issue of having empty servers waiting for players. It's handling multiple, it's so-called fleets, but you can have multiple game server versions working at the same time. If your game, for instance, requires different game server for different maps, different versions, different clients, so it handles that issue. It's open source. It's under Google's support, so this is created mainly by Google's employees, but it's open source. It's generic, meaning that it can run wherever Kubernetes is working. So we have tested Agones in Amazon, Azure, and GCP. So it was working fine. So it's nothing to be worried to be that it's gonna vendor lock you. Also, there is the service called the most generic service name that they could think of, the game servers, and it's in GCP. This is kind of Agones in the cloud, but in reality, you still have to install Agones on your own, and it's only a control plane for Agones. Generally it gives you a nice admin panel for Agones, and the extra thing it adds is that you can hook up multiple installation of Agones into this service. So it makes coordinating something between clusters easier. Oops. There is, but that was kind of low level, meaning that you had to install a lot of things on your own. But there is another service, games called Gamedev. This service is from AWS, and this service has a part dedicated to game servers. And while everything that I told you before might be understood as a infrastructure as a service level, this one is more platform as a service. And that means that you don't have to take care of thinking about operating systems and machines and things like that. You only have to upload your game server to this service, and that's it. So it handles a lot of issues for you, and first of all, it takes care of scaling, meaning that you declare how many servers you'd like, the minimum, maximum, how many spare game servers you'd like, and that's it. So it makes it easier to handle that. And also it has a component of server assignment. So with that, you don't have to have your own application that will handle assigning player to a server. You can use the Gamedev SDK to say, okay, I have a player that wants to play a game. Give me an empty game server that will be, for instance, most cost effective with lowest latency, or I'd like one in that given location of the data center. So this is a lot of easier for to deploy the game servers, to run them. Of course, at the cost of being more elastic. One thing I haven't mentioned before is a thing that cloud services offer. It's not a widely used feature of a cloud. There are so-called those ephemeral instances, and those are named differently in with different cloud operators. But those instances is a way for cloud vendors to oversell their capacity, meaning that, okay, we have some spare computing power, we will give you that for 10% of the price, so 10 times cheaper than the usual virtual machines, but with some catch. The catch being that you can be kicked off from that server in a matter of like 10 seconds. So, but we give you a guarantee that this won't happen in next 30 minutes. So this, if your usage pattern is that your game sessions are like, for instance, 10 minutes, 15 minutes, this is the great way to save a lot of money. They can be a lot cheaper. Yeah, and AWS called them spot instances. Google called them preemptive instances. So this is a thing to think of, and I'm telling you that because AWS has also a variant of their services called Fleet IQ, which is closer to the level of infrastructure as a service, but and you work more with server templates than the containers, but gives you the advantage of the possibility to use the spot instances. So you handle some infrastructure stuff on your own, like creating those server templates, but on the other hand, you can have your game servers running for a lot lower price. And in the documentation it says that it works with Kubernetes, but it's you have to hook up a lot of things on your own. So on paper it works, but it's a lot of manual configuration, building everything on your own. So let's move to another type of service, because there is PlayFab from Microsoft. PlayFab is a full Liveops suite, meaning that it's a bundle of services that will help you run your game. And if you do not want to take care of anything regarding your online gaming, you can just use PlayFab. This is they group their services into multiplayer services, Liveops, and analytics, and this contains everything from running the game server, handling networking, some analytics, meaning that you can collect all the data about everything what's happening within your game, analyze that, apply some machine learning to that. With Liveops, you can have things like user profiles, inventory, currencies, in-game stores, so tons of different stuff. And having that, you can run your game without any kind of services running on your own. And like I said, there's the component for running game servers, and it's called multiplayer game servers. Also, this is platform as a service, meaning that you have to only upload either your binary or even you can use your Kubernetes, your Docker containers to put it into the registry, and also that's it. You tell PlayFab how many instances of those containers you'd like to have, and it spins up those. So it's very easy to use that when you already have you already worked with containers. You have your binary Dockerized, You just upload it to the registry, and that's it. There's also from Amazon there is a service called Thundernities, and it's more or less competition to Agones. This is implemented in a bit different way than Agones, but generally it serves the same purpose. It makes the scaling of the game service more in line with requirements of the game dev. Like you can create you can tell Kubernetes to spin up some game servers to be pre-allocated, to pre-warm them. It also helps with the issues of networking, like I said before. It handles exposing game servers to the internet, to the public internet more easily. It shares the same SDK as PlayFab, so it makes it easy to migrate migrate your game servers between Thundernities and PlayFab, it also allows you to, thanks to this migration, you can use those cheaper instances. So it's quite easy to integrate at first to use PlayFab when you are just starting, and when you have outgrown the what PlayFab offers, you can migrate to Thundernities easily. But that was the game server part. But there are some additional services that are being offered by the cloud vendors, and first of those is matchmaking. Matchmaking, of course, a very important part of every multiplayer game. It makes the game more enjoyable. It's generally, if you get a bad match for the game, it ruins the experience. For instance, if there's a problem with connectivity between the players, or the players are on totally different levels, it makes the game bad. So for matchmaking, there is the Open Match. Open Match is, like the name suggests, open source solution, also from Google. You can host that on your own. I didn't test it personally, because when I was at the stage of testing matchmaking components, it was still early beta. But this service, this project is evolving quite quickly. So it's something worth looking at. And also both PlayFab and the Gamedev have matchmaking components inside them, so you can use them. What's worth being mind of? It's for our experiments, we created our own matchmaking, because neither of those allowed us to use the matchmaking workflow as we wanted. They had some pre-existing concepts, some design ideas that were not aligned with our requirements. So when checking out those, just check what's the flow, what's the architecture required for implementing those, because it might be just not for you. Another interesting thing is GameKit from Amazon. GameKit is something that brings cloud infrastructure closer to Gamedev, because this is a plugin for Unreal Engine, and from within the editor you can declare what kind of this is already in official distribution, but it's still quite early, so they do not have a lot of the services in the offering. But for instance, you can have achievements. If you need achievements in your game, you can configure it from Unreal Engine editor and deploy all the infrastructure that's necessary for your game. And also it handles the user authentication. So if your game needs profiles, it also handles everything from the editor. So it also is using some on the cloud infrastructure level. It's using some well-known technologies for technologies well known for DevOps. So when you have some different needs than the standard, it's easy to modify it. It's using Terraform scripts to build the infrastructure. So it's using some well-known technologies. GameSparks. This is also a very interesting project because this is a project that's handling some backend services needs like achievements, like profiles, and so on, but without any persistent infrastructure. It deploys the code as functions, and because of that, it's like I said before, it's pay as you go. So if your game is just starting, you don't have to pay for the whole time it's working. But for now, it's some early beta, and also it doesn't cover a lot of services, but it's also very promising. Some issues that one might have with using those services. First of all, costs, because it's paying someone to do your job, so they have to earn somewhere, and while it might be cheaper to build some services on your own, it might be more expensive to support them. So that's one thing to bear in mind. You have to calculate if it's maybe on paper those services are expensive, but maybe it's more expensive to hold to employ a whole team of IT specialists to monitor and fix those. Networking, those services have to communicate somehow, sometimes with your infrastructure. So sometimes it might be problematic to hook everything up together, but that's mostly for some more complicated solution. Hard-coded concepts, like I said, with the matchmaking. Some of those services were designed with some flow in mind. So it might not fit your needs. Vendor lock-in. When you hook up to some of those services, most likely you are tied with those for some time if you are not using the generic solutions like Kubernetes or Bare virtual machines. So sometimes you have to stick with the vendor for some time. It's not a bad thing, but it's something to be considered. Most of those services require, when you integrate, for instance, your game servers with, it requires modifying your game server, like integrating SDKs and so on. So you have to make sure that it's gonna work together. If for instance, if some SDK for the languages that you are using exists, so that's also to be thought of. Scale, yeah, that's the problem of outgrowing services. Some of those services are not do not scale above some level or become terribly expensive above some level. So and on the other hand, some of those services are too difficult to employ. For instance, if you don't have someone who is a specialist in DevOps. So there's some scale level that those solutions work for. Okay, so let's sum up some takeaways. going into software as a service is a trade-off. Like you pay pay someone to take care of those services for you, but you lose some flexibility. Software as a service or any kind of cloud solution has some concepts that might not work for you. Vendor locking, you have to remember that the problem of being tied with a single vendor exists, but it's okay if you take that into account. Quite often you can mix and match, meaning that you can take some part of only a part of some service. For instance, you can have from PlayFab you can use the backend services because it's quite developed, and from other services you can have the game server hosting and matchmaking, for instance. Check what's the stage of your game. So maybe it would be a problem if you quite soon that you outgrow the services, and often check for updates because those some of those services are quite fresh and they develop very quickly. Some of those are mature, but also there's always something new. What about our guy? Our guy has servers in the cloud, so he doesn't have to take care of the hardware. The scaling is easy. He can have some metrics to drive the scaling of the servers. So he doesn't have to manually scale them. He can deploy all the backend services in the cloud. He can pay someone to run those services. So his life is easier. The game is running more smoothly. So the gamers have better experience, and everyone is happy. Thank you very much. Of course, we are hiring. So if you are interested in working on some online projects, just reach out to us. Okay. Any questions?
Hi, I'm Eduard, and I want to ask you about Kubernetes and cloud services. That, for example, I decided to use Google Cloud Service, and I know that if I need to have high performance, I need to configure some hardware configuration like extra. Let it be 256 RAM and 1 terabyte of hard drive.
Storage.
And how Kubernetes will be auto-scaling if there are a lot of this cloud service will not how to say have enough performance. So is it do not allow other players to join, or it will be by extra memory?
Okay. So there are a few ways to solve that. First of all, for Kubernetes, when you define your workload, you can define memory and CPU requirements. So Kubernetes will make sure that it will not put too many pods on the same node. So that's the first thing. And if you want to replace the weaker machines with more powerful ones, you can put the node in a shutdown state. So, for instance, if you are using Agones, you can make sure that Agones will not assign the server to new players, and when all the players are gone, it will just shut down, and this virtual machine will be destroyed, and the new one will be used. So first of all, you can evict anything that's happening on that machine, and also Kubernetes will make sure that it won't put too many pods on a weak machine, because you declare requirements of the pod by memory and by CPU time.
Okay, and one more question that about Docker. If I'm not mistaken, you said that it doesn't matter if you run it on Windows or Linux, but on Windows, Docker will run additionally lightweight virtual machine to run another container. So it depends on performance. Linux will be better.
Yes, exactly. So anything besides Linux will have some overhead, because for macOS and for Windows, some extra virtual machine needs to be spun. For Windows, it's a little bit easier because you can use Linux subsystem for Windows, and it makes it a little bit easier. But still, you will get the best performance on Linux, Linux development workstation. So while it will work the same way, it will have different performance on different operating systems.
Thank you.
Hi, Leszek, thanks for presentation. And I have a question in terms of downsides. So it's all the time it's trade-offs. You're considering like pros and cons, and you are working on a best solution. So in terms of cloud, you put some risks on their shoulders, but also you should consider if something goes wrong. Consider SLA, available SLAs, also cost of that. So I'm just wondering if you had any experience with the support when something goes wrong. And second question, do you have any solution, backup solution or redundancy solution? So not putting every eggs in one basket. So if you have something on premises for your sole control, so everything you can control and rely on.
Okay. First thing about support from the cloud. When we build the solutions using Kubernetes, our one of main concerns is for it to be self-sufficient. So if anything goes wrong, we can just scrap everything, build it from scratch, and it should work. So right now we are focusing on not having anyone on call, for instance, to make sure that someone will fix anything. Our approach is that it should when it's working, it's working. So something, of course, happens that some VMs just break, or we have the noisy neighbor issue of some other customer on the same issue using too many resources. But like I said, it should fix on its own, because most of our software is stateless. So we can just kill one pod or destroy a virtual machine, and it will, when we recreate it, it will work properly. So we have everything defined. All of our infrastructure is defined as a code, so we can just wipe everything, run our scripts, and it will be brought back. So that's also a thing to consider. And about the second question, yes, we were thinking about how to approach the issue of not having everything in one with one vendor. And at this moment, for instance, we decided for Gwent, we decided to use cloud as a way for overflow, meaning that we have some baseline capacity of our own dedicated servers, and we spin up something extra only if we cannot handle the traffic on our own hardware. So yes, we are using that. We have devised a very nice architecture for using actually multiple clouds. Our architecture works on Kubernetes and Kubernetes Agones, and we have connected that to every major cloud vendor, and it was working fine. Our idea was that we want to be able to use some better locations of different vendors, some better pricing for them, some availability issues to overcome. So our architecture is not limited to a single operator. We can use any of them, and it worked flawlessly. So we haven't had any issues because Kubernetes is more or less the same with any operator.
Thank you, Leszek.
Thank you very much.